Moles. They are mystical creatures that live under the ground. Psyche is really a unit of measurement.
A mole is 6.02 times 10 to the 23rd of anything. The formula mass in grams of a substance contains 1 mole of particles. It is important mole conversion factors. 1 mole equals 6.02 times 10 to the 23rd, which equals formula mass in grams.
For example, this problem wants to know how many atoms you have if you're given 12.21 grams of carbon. If you're given 12.21 grams of carbon, every 1 mole you have 12 grams of carbon. Every 1 mole you have 6.02 times 10 to the 23rd of atoms. Your units cross out and you end up with 6.02 times 10 to the 23rd atoms. This problem wants to know how many molecules you have for 18 grams of water. If you have 18 grams of water, every 1 mole you have 18 grams of water. Every 1 mole you have 6.02 times 10 to the 23rd of atoms. Your units cross out and you end up with 6.02 times 10 to the 23rd atoms again. The last problem wants to know how many grams you have if you're given 3.5 moles of sodium chloride. If you have 3.5 moles of sodium chloride, for every 1 mole of sodium chloride you have 58.5 grams. Your units cross out and you end up with 58.5 grams of sodium chloride.
It's on the mole. The mole is an incredibly important term, but remember, it's just a number. It's Avogadro's number. Why is it important? Well, it allows us to deal with the massive number of atoms that are found in a mole. Is simply Avogadro's number. It's a number. It's 6.02 times 10 to the 23rd. Where does that number come from? It's derived from the number of atoms in 12 grams of carbon-12, but it just gives us a usable amount of material that we can work with in the lab. So if we're ever looking at a reaction like this, the coefficients, remember, are going to represent the moles. But it also serves as a bridge, most importantly, a bridge between the mass of an object and the number of particles that are found within that object. And so where does the name come from? Avogadro was an Italian chemist, worked many years ago in the early 1800s. And so he came up with Avogadro's law. Basically, as we increase the volume of a gas, he proposed that we were increasing directly the number of particles that are found within that. Didn't matter what the gas was. Now, he died before they actually came up and quantified this idea of the mole, but we still give him credit for that early work. And so 1 mole is 6.02 times 10 to the 23rd. But it's just a quantity. It's like if I have 1 egg, we call that an egg. But if I have 12 eggs, we call that a dozen. And so a mole is just a number. We could have a mole of anything. But it's most important when we're dealing with chemicals. To give you an idea of how massive this number is, imagine if I had a mole of marbles. So just regular marbles like this, and I were to start covering the earth. Well, I could cover the earth in marbles, and that covering of the earth would be 3 miles thick. And so there's a huge amount of numbers in Avogadro's number. And so when you're dealing with even small amounts of a compound, small amounts of an element, you have to understand that you have that many atoms that are found within there, massive amounts. Again, it forms a bridge. It forms a bridge between the mass of an object and the number of particles that are found there. And so it's really important that that kind of a bridge forms this bridge between the mass of an object and then the number of particles that are found within that. And this is where sometimes people get confused about the mole when they're trying to make these mole conversions. And so let's say I had 9.01 grams of water. It's about almost 10 milliliters of water. And so that'd be about 2 teaspoonfuls of water. And let's say I wanted to figure out how many molecules of water are found inside there. Let me show you how the mole can act as a bridge. So we have 9.01 grams of water. The mole is going to act to convert that into the number of particles. So first we use this mole conversion. Remember, 1 mole of anything is going to be the atomic mass of that in grams of water. So where am I getting the 18.02? I'm adding the 1 oxygen, 16, plus the 2 hydrogens. And so 1 mole of water is going to be 18.02 grams. And so what I could do is I can cancel those grams. So now I've converted it to moles of water. Now we use Avogadro's number. And so I'm going to take 1 mole of water is equal to a number of molecules of water. So 1 mole is equal to Avogadro's number of that. I can now cross off my moles, and now I can solve for the number of molecules of water. And what I get, the math is easy here since I'm taking this dividing by 18.02, we get 3.01 times 10 to the 23rd. And so, I mean, wrap your head around that for just a second. 2 teaspoonfuls of water, the number of water molecules that are found in there would cover the Earth in marbles, if we converted those molecules to marbles, 1.5 miles.